Before we go on to the new stuff from 6.4, I thought I'd give you this little review from 6.3. So I want you to look at these two triangles and just decide which one of those is the incenter and which one of those is the circumcenter. So pause the video real quick, see if you can figure it out, and then I'll go through it with you. Okay, so if you look at this first triangle, these are the angle bisectors. So if you look at these ones in green, that's an angle bisector, that's an angle bisector, and that's an angle bisector. That means that point where they cross is the incenter. Okay, so that one's the incenter. Remember what that means. That means that point is equal distance from all the sides of the triangle. So if I measure from there and I could draw a circle on the inside, that wasn't good, but that distance from there to there to there, it's equal distance from all the sides. Okay, the second one in red here, these are the perpendicular bisectors, right? It cuts the side in half and it's perpendicular, right? Cuts the side in half and it's perpendicular, same thing there. So that point is the circumcenter. And what happens there is if you measure the distance, it's equal distance from all the vertices. So measure from there to there to there to there, it's equal distance from all the vertices of the triangle, okay? So circumcenter. Make sure you know those two. There's different centers of triangles. So we've learned two of them, incenter and circumcenter. We're going to learn two others today, and you'll be responsible to know what these are. So this is just a memorization thing that we're going to be going through. Okay, our learning goals for today then. I can use medians and find the centroids of triangles, and I can use altitudes and find the orthocenters of triangles. So these are two different types of centers. We're going to talk about the centroids and the orthocenter. A median of a triangle, just a definition, is a segment from a vertex to the midpoint of the opposite side. So if I have a triangle and I find the midpoint over here, so that's the midpoint, and then I go from the vertex to the midpoint, that is the median of the triangle. Right, so a triangle has three medians. I could find the midpoint over here. That'd be the median. I could find the midpoint over here. Okay, that would be the median right there. Hey, what we're going to do right now is we're going to go to GeoGebra real fast, and I'm going to construct the medians of a triangle, and there's a pattern that happens with these, so I want to show that to you. So I'm going to pull that up, and we're just going to make a triangle. Doesn't matter what the triangle looks like. So there's my triangle, and we want to construct the medians. So to do that, I need to find the midpoints of each side of the triangle. So if you look right here, there's a button under construct that says midpoint or center. So I'm going to click on that. If I click on that segment, it puts a point at the midpoint, midpoint. Oops, I missed that one. Midpoint. Let's undo that. Okay, so we're going to go here, midpoint of that segment, midpoint of that segment. And then the median is the segment that goes from the vertex to the midpoint of the opposite side. So median, midpoint is the way I remember that. Vertex to the midpoint of the opposite side. Vertex to the midpoint of the opposite side. Okay, what I want to point out is there's some relation. So first of all, they're concurrent. So they all cross right there. This is called the orthocenter. I'm going to put a point there in the middle. And then what I want to show you is some of these measurements because there's a pattern that happens here. If I measure the distance from there to there, and from there to there, and from these two, and those two. Okay, look closely at those distances, and what you'll find out is this, right? This segment, 3.2, is half of that 6.4. This 1.6 is half of the longer segment there, which is 3.2. The shorter segment, 2.9, is half of that longer segment, which is 5.8. So you can kind of think of it this way. Is you could take this line, you could divide it into thirds, right? This one's 1.6, 1.6, and 1.6. So this is 1/3 of the entire segment. Okay. This part, from there to there, is 2/3 of the entire segment going that direction. So that is the relationship that happens when you find the centroid. By the way, the centroid, you don't need to know this, I'll never test you on this, but is actually sometimes referred to as a center of gravity. In other words, if you had a triangle like that was a flat, like a piece of wood or something, if you found the centroid and put your finger right on the centroid, it would balance the triangle perfectly. So that's kind of cool. But the main relationship you'll have to know is what we just talked about here. I'll show that to you here. This is a theorem in your book. Here's a definition of a centroid. It's just where all the medians meet. Here's our theorem on centroids. So all it says is the centroid of a triangle is 2/3 of the distance from the vertex to the midpoint. In other words, that segment is 2/3 of that entire segment. What that also means is if you look at the shorter segment, this segment is 1/3 of that whole segment. Same thing here. That one is 1/3 of the whole thing. That one is 2/3 of DC. That one is 1/3 of EA. That one is 2/3 of EA. Another way to think about it is this, and to me this is easier, you'll see on some of these problems, is that this segment is twice as long as that one, is double that one. This segment is half of that one. This segment is half of that one. That's another way to think about it also as you go down through here. Okay, so this one says RST point Q is a centroid, so it's given to us that that's a centroid, and SQ equals 8. It wants me to find QW and SW. So instead of trying to find the full segment, just notice this is the longer piece, right? SQ is the longer piece. This is the shorter piece. That means this one is always half of the longer one. So if this one's 8, that one's 4. SW, the whole thing then would be 12. So just notice, right? 8 is, I times it by 2/3. 2/3 of 12. 2/3 of 12, right? 2 times 12 is 24, divided by 3 is 8. 1/3 of 12, right? 1 times 12 is 12, divided by 3 is 4. So, right, this is 1/3 of the whole piece, that is 2/3 of the whole piece. But the easiest way to think about it is, if I have the long segment, I cut it in half to find the short segment. If I have the short segment, I can double it to find the long segment, and then I can just add them together to find the entire thing. This one's a little harder because it gives us points, but it wants me to find the coordinates of the centroid of triangle RST. So it says the points are at 2, 1, so this is R, 2, 1, 5, 8. So this one up here is vertice S, and T is at 8, 3. So there's my triangle. And it wants me to find the coordinates of the centroid. There's a couple ways we could approach this. I think I'm going to try to find the midpoint of this RT. So we've done the midpoint formula before, but if you need a reminder to find a midpoint, you take the 2x coordinates, you add them together, and divide by 2, right? The halfway point between the x's. And then you take the 2 y's, you add them together and divide by 2. So let's find the midpoint of RT. So I take, I'm doing R and T, those two. So add the x's together and divide by 2, and add the y's together and divide by 2. So that'd be 10 divided by 2 is 5. That'd be 5, 2. That looks right. That looks like our point right there. Well, that works out nice because that whole segment right there then is my median. And now I can find where the coordinates of the centroid. Remember the relationship. If that's a whole segment, then the centroid has to split into those parts to 2/3 and the 1/3. So let's find the total distance. We can just count that. That's 1, 2, 3, 4, 5, 6. So the distance from S to the midpoint, I'm going to call that point M. The distance of SM is 6. So if I find 2/3 of that, what is 2/3 of 6? Let's times those. 2 times 6 is 12, divided by 3 is 4. Right, 6 over 1. That means the other one, right? 1/3 of 6. Right, 1 times 6 is 6, divided by 3 is 2. So that, I know my segments have to be 4 and 2. So I'm going to come down here. I'm going to count down 4 and then count down 2. By the way I know that it's down here, I could go up 4 and up 2, but if I think of the midpoint of the midpoint of this side, right? It's got to pass through. I know it's got to be somewhere in that area. It can't be up there. That point wouldn't work. Okay, so that's the coordinates of the, if I can find the coordinates of that point right there, I have the coordinates of the centroid. So if this point is 5, 2 right here, this point is just up 2, so that would be at 5, 4. So I had to find the midpoint, and then I had to divide this segment, right? That segment right there. I had to split it into 1/3 and 2/3 pieces. You can times by 2/3, you can times by 1/3, and then from there you can figure out where that centroid would end up being. Here's a little problem. It says, right, there are 3 paths through a triangular park. We got the little picture over here. Each path goes from the midpoint to one edge of the opposite corner. What that means, right, is that goes from B to the midpoint, that goes from A to the midpoint, and it goes from C to the midpoint. That makes that the centroid right there. Number 1 says, find PS and PC if SC is 2,100 feet. So we know that the entire thing, SC is 2,100 feet. So I'm going to take that and I have to divide it into those pieces. What you can do if you want to, this may be the easiest way, is you can just divide it by 3. 2,100 divided by 3 is 700. And what that means is you're dividing this into thirds. So from there to there would be 700. And then if I split this one in half, like that would be 700, and that would be 700. So really you're dividing it into thirds. So the question is, what is PS? Well, PS is 700 feet. What is PC? That's 2/3 of it, so I have to take the 700 and 700. That would be, sorry, over here, that would be 1,400 feet. Okay, next one says find TC and BC if BT is equal to 1,000. So let's look at that one. So BT is equal to 1,000. And it wants me to find TC. Well, remember, this is the median, which means T is the midpoint. So if BT is 1,000, that means TC has to be 1,000. And then BC, the entire thing, you would just add those together, so it's got to be 2,000. Okay, find PA and TA when PT is equal to 800. So PT right here is equal to 800. So that's the smaller piece. So the longer piece, AP, out here has to be double that, 1,600. And the whole thing would have to be, you add those together, it'd have to be 2,400. So that would be, PA is 1,600, and TA, the entire thing, it would be 6,400 feet going across there. Let's just do one of these. I want you guys to try one of these. You can use graph paper, or you can just put on a regular piece of paper. But let's see if we can come up with the coordinates of the centroid for one of these two. So why don't we do, let's do number 4. So I just placed my 3 vertices on here. I have 2, 5, which is F. I have 4, 9. Whoops, I put that in the wrong spot. Let's try that again. So 4, 9 is G, and I have 6, 1 is H. So this is my triangle. And I want to find the coordinates of the centroid. So when I look at this, I've got to find the midpoint of one of the sides. I'm not 100% sure, but this looks an awful lot like if I found this median right there. That looks like the midpoint. It's going to be horizontal, and that will make it really easy to find. So I'm going to try this. I'm going to try to find the midpoint of GH. So let's do that. I'm taking G and H and finding the midpoint. So I add the x's and divide by 2. 4 plus 6 divided by 2, that would be 5. Add the y's. 9 plus 1 divided by 2, that is also 5. So I come up here. If I go to 5, 5, it is that point. That works out nice because now I can just divide that, and that segment is 3 units long, right? So that makes it easy because one side's going to be 2 and one side's going to be 1, right? I'm going to have to go either 2 in here and then 1, or go 2 and then 1. I just got to figure out which way it would go. The way I would picture it, if this midpoint looks like somewhere in here, I think this is going to be the other median. So it's going to be this point right here. So I've got to go 2 from that way and 1 from that way. So that puts my coordinates at 4, 5. Okay, that'd be the coordinates right there of the centroid. So those can be a little bit tricky, but if you always focus on try to find the midpoint of one of the sides, and if it's either a horizontal line or a vertical line, that makes it really easy because you can divide it into the 2/3 and 1/3 pieces pretty easily. Okay, the last thing we're going to talk about, this is the last center of a triangle you're going to have to know. This is called the, we're going to start by talking about what an altitude of a triangle is. You guys have seen this before. An altitude is the perpendicular segment from the vertex to the opposite side. I'll show you what that looks like here in just a second. But it's also known as the height of the triangle. So I'm just going to draw a triangle here really fast. If you have an acute triangle, right, if I go from the vertex perpendicular to the opposite side. Now notice it doesn't have to split the opposite side in half. It just has to be perpendicular to it. That is the height of the triangle or the altitude of a triangle. One thing I do want to point out is if you have an obtuse triangle, something like this, you guys have seen this before, but I just want to remind you. If I want to find the height of this triangle, I go from the vertex perpendicular to the opposite side. Sometimes you have to extend that side out like that. So this would be the altitude right there. Okay, that's the height of the triangle. Okay, going down that direction. Okay, so if it's an obtuse triangle, sometimes you have to extend out the opposite side to make it perpendicular, right? You want that to be perpendicular, go in that direction. If you have a right triangle, interestingly enough, if you have a right triangle, if you look at it, if I go from the vertex perpendicular to the opposite side, right, it ends up being one side of the triangle. So you can kind of see how altitudes look a little bit different depending on if they're obtuse, acute, or right triangles. What we're going to do is we're going to construct the altitudes of all three altitudes of a triangle, and we, like before, you probably won't be surprised that they're all concurrent. So we're going to go on GeoGebra, we'll construct that, and then we'll talk about maybe some of the relationships. So we've got, I'm just going to make me a triangle here. Again, it doesn't matter what type it is. Okay, then we're going to construct the altitude. So to do that, we need a perpendicular line. So we're going to come here. We're going to go from the vertex perpendicular to the opposite side. So it looks like that. And then do it for all the sides. I'm going to go from the vertex perpendicular to the opposite side. You'll notice on that one, right, this is an obtuse angle. So I need to extend that side out to actually see where it would go there. And then I'm going to go from the vertex on this side perpendicular to the opposite side. So I'm going to change those just so we can make them, I'm going to make them a dashed line. These are all the altitudes of the triangle. And what you'll notice is that they cross on, in this case, it's an obtuse triangle, they cross on the outside. I can take it and move the triangle around. Let's make it, so this is an acute. You can see how they cross on, actually that last one is acute also, but they cross on the outside. If I make it, I can move that around. You can see where that, this is called the orthocenter. You can see how it moves around depending on how I make it. Okay, now it became acute. You can see it's on the outside. If I make it a right triangle, it's actually right there on the vertex of the right triangle. Okay, if you do that. You can kind of see what happens as I move that around in different spots. Unlike the other problems we've done, so that's called the orthocenter, which is right there. It's where all the altitudes of the triangles meet. This one doesn't really have a lot of special attributes. Like we talked about, the incenter was equal distance from the sides of the triangle. The circumcenter was equal distance from the vertices of the triangle. And then the medians we just did, they form that, they split the medians, the centroid splits the medians into those 2/3, 1/3 segments. This one doesn't really have like a super neat attribute here. So we're not going to spend a lot of time with this. Out of all the centers, we'll spend the least amount with this one. Let's just do one example here. It says find the coordinates of the orthocenter with the vertices at -5, -1, -2, 4, and 3, -1. So let's do this one problem. So I've got -5, -1, which is right there. There's x. Y is at -2, 4. So there's y. And z is at 3, -1. there's Z right there. So here's my triangle. And I want to find where the coordinates of the orthocenter is. So to do that, this is a little tricky. I'm going to have to come up with the equation of two lines and find where they intersect at. So the easiest altitude to draw is at Y. And the reason why is because this side down here is horizontal. So if it has to be perpendicular, right, that's got to be a vertical line. So that line right there would just be x equals -2. I know my orthocenter has to be somewhere along that. The harder one is I've got to come up with an equation of another line for the other altitude. So if I go, like, for example, from x over here, that points at -5, -1, and I want to draw the line that's perpendicular to this side over here. Let me outline that in black. I want to find the one that's perpendicular to that. The problem with that is that I need to know the slope to make it perpendicular, right? So let's find the slope. If I find the slope of this line, I'm going to go, it goes down 1, 2, 3, 4, 5, and it goes over 1, 2, 3, 4, 5. So that slope, the slope of this line right here is going down 5 and over 5. The slope's a -1. If I want to find the equation, this altitude has to be perpendicular. So that means I've got to do the opposite reciprocal of that. So the slope of the line I'm trying to find, this line, let me outline it in a different color. I'm trying to find the equation of this line right here. It's got to have a slope of 1 because it's the opposite reciprocal of that. And it's got to pass through that point right there, which is -5, -1. Okay, we did this a couple lessons ago, but we want to find the equation of the line. We can use this formula. So we're going to plug our information there. I'm going to go y minus -1 equals my slope, which is 1, times x minus my x coordinate, which is -5. So I end up with y plus 1 equals 1x, that changes to a plus 5 minus the 1 over. So I end up with that y equals x plus 4. So I want to find out, where does that line, right, outlined in black in there, and this line, where do they cross at? Because that point right there will be the orthocenter. So to find that, I can just do substitution. If I take this -2 and put it in for x right there, that will tell me what y is equal to. So y is equal to -2 plus 4. Well, -2 plus 4 is 2. So my point is at -2. Sorry, I was off by a little bit. The actual point where they should have crossed was right there. So my line should have been up just a little bit higher right there. Okay. So there's my answer. The orthocenter is at -2, +2. That's a little bit tricky. Again, we're not going to get too caught up on this. Orthocenters, again, there's not really any special attribute with those. So you need to know what it is. Maybe I'll have one problem where you have to find where it is, but don't get too hung up on that. So just to finish things off, here's a summary of all the different things we've done so far. Right, if I draw all the perpendicular bisectors, that forms the circumcenter. That point is equal distance from all the vertices of the triangle. Right, circumcenter, equal distance from the vertices of the triangle. If you do all the angle bisectors, it forms the incenter, and it is equal distance from all the sides of the triangles. If I draw all the medians, it forms a centroid, and the centroid forms those ratios, the 2/3, the distance from each of the vertices. The altitude, if I draw all the altitudes, they're all concurrent. It forms the orthocenter. There aren't really any special properties of the orthocenter. This is everything from both 6.3 and 6.4. That's where all of these centers of triangles come from. You need to know all of these. So whether you need to make a little chart or flashcards or something, but memorize each one, the circumcenter, incenter, centroid, orthocenter. Know how they're formed, right? Over here, know how they're formed, okay? And then know their properties. And You'll probably on your test somewhere have just a matching thing where you have to match those questions with each other to see how they're formed.